Hello guys, and welcome to another video. Here I'm going to talk about a bit EasyRPG as well as the related library liblcf. Basically going to talk about the process of porting something to the Dreamcast. Now, I should warn you guys, even though it works on Flycast and I did a video about it, it's not actually fully working on real hardware. It is probably initializing the video, but then it is crashing shortly after. I have yet to debug this because it seems to be a CPU alignment issue, which unfortunately Flycast does not properly emulate. So let's start first with the player. Now, my first attempt was looking a lot like this. It was still using SDL, as you can see. And of course, I had to fix a few bugs because, if I would not put in like these IDEF things, it would not even compile. I also reduced the frequency for, the MIDI playback, reduce the cache size. That was a suggestion made by the EasyRPG devs. I also disabled the Japanese fonts. They were 1 megabyte big. So on something like Dreamcast, which only has 16 megabytes of RAM, that's a big portion of the RAM being taken for essentially nothing. Now, for the config, right now I'll just place it in RAM, but later I just return null instead. So basically no config file being supported. Now, this is important, of course. On the Dreamcast, we load games from the CD drive. So I just forced it to a path, a hard-coded path. Then people can just play from that. Now, this is something interesting. Access, even though it seems defined in Callisti OS, it's not actually working. So I had to use my own variant. This actually took me a bit of time to figure out because I wasn't sure if it was checking if the file exists or if it was checking if a folder exists. And it turns out it was for a folder. So yeah, it's not totally accurate, to be honest. It should be more like access. But yeah, it works for what I want. Then I had to fix this bug, which actually was broken by an EasyRPG developer, and he forgot to include this line. Then I did also a pushback, but that turned out to be not necessary, as you're about to see. Then, of course, I forced the frequency, force 16 bits stereo, then force the bitrate, well, the BPP, my bad, to 32 bits, because EasyRPG internally works at 32 bits. So if you were trying to say that like 16 bits, it would actually crash at some point, even though it would look properly. There's currently a memory leak issue. Basically, it would allocate a buffer that is too small, and EasyRPG would try to draw outside of that allocated buffer. Unfortunately, because if it's like a nest in mess of OOP, I was never able to figure out what was causing the issue in the first place. It's really confusing to look at. But anyway, on the Dreamcast, I just disabled like the if condition. It just forced it to bleed fast. And now this is interesting. When I first tested EasyRPG, it was a black screen. I was getting audio, but it was black screen. But then I was reminded that for hardware surfaces like the Dreamcast, you need to use flip. Once I did that, it works. Then I disabled the cursor because it was showing up on screen. And then there was this weird Callisti OS specific bug. The standard C++ library does not have these defined. Now, fortunately, in the C standard, you can just call them as is, and it's going to work. Now, when I did this initial port, now, first of all, I did not actually test this on real hardware at the time back then, but also, Was a bit. I would get memory allocation issues quite often with this build. So what I did next, well, I did drop memory consumption a bit. Or at least I tried, but as you can see, it was just a mess. In fact, it didn't drop memory consumption much. All I did was basically disable the logos and skip them. That's what really saved memory. Then I did more modifications. I believe these ones were more extensive. And yes, they were, because I was replacing the assert functions with real asserts. And I finally added its own backend for the Dreamcast. So, resolution is set here, 32 bits, 240p. Now on the Dreamcast, there's actually no alpha channel for the final frame buffer. It's just 32-bit wide, but the alpha bits are ignored. So yeah, it's basically a faster way of writing, more than 24 bits colors, but with like a 32 bits buffer. So you don't have to do aligning and stuff like that. And yeah, and I also made sure to test the controls. So this is Dreamcast specific. I actually took the code from the 3DS port. And then there was this function that Ian shared with me. It's basically a fast copy with like SQ, my bad. Now you could use DMA, but if you sometimes DMA is faster, other times SQ is faster, and most of the time people have found SQ to actually be faster than DMA. So that's what I ended up using. And yeah, now I did not replace the audio, it's still SDL, because I was not able to get it to work, actually. So the audio is still like that. I greatly simplify it, and it basically just a couple of lines, really. But yeah. Now this was still not working on real hardware. It still isn't, but yeah, get the idea. So I decided to redo my branch. And this time, well, first of all, I disabled logs because they were showing up on screen and they were quite annoying. And yeah, this Dreamcast specific stuff. So basically, I rebased my changes. I removed a couple of useless stuff on PC. Translation is now a stub. I noticed it was taking quite a lot of code size and basically not being useful. So I did a stub that returns basically nothing, just enough to barely work. The translation stuff is only used for if you do like your own translation on top of a game. It's not often used, but yeah. So fix errors and other stuff. So I actually pushed this fix upstream because I noticed it. Now this one is more interesting. So I was looking into dropping the leave FMT dependency because it's quite big. It's this library. Now, what you may not know, it's actually part of C++ 23 or 20. And those are standards. And if you turn on like the C++ 23 or 20, you have access to std format. So with std format, you can essentially drop the dependency. Now, these are not actually correct, but since they are not used, because I disabled them, it's still working. These bits are not working either. I was not able to get it to work. out of the box with standard formats. There's some weird issue regarding parsing strings and stuff. I've not been able to fully figure that out. And as you can see, the rest of the source code is really switching everything to STD format. So aside from a couple of stuff, they are mostly identical. I was quite shocked to be honest. And it was dropping about 200 kilobytes along with another change. So let me show you. So in the LCF, there's another dependency that was not breaking, but it was problematic, especially in terms of size, because doing these changes dropped the size by like another 200 kilobytes. Yeah, so they were using a span implementation in C++ for the older C++ 17 standard. So, but since we use like C++ 23, we have access to SCD span. That's what I did, and it works. The size is much smaller. I greatly appreciate that. And I also removed a bunch of debugging stuff, mostly because they were depending on. I recall that they had like a dependency on the libfmt, so I didn't have to deal with that, and that saved a ton of space. I also did try GCC 15 to see if it worked. It reported a few errors, but it did not really fix my issue, unfortunately. So that's a bit of a bummer. Yeah, and it noted this issue. Now I haven't really tried in depth, but it seems to work the same as before. It's just that it's fixed. And yeah, I did try to optimize things. I actually made a mistake here. I replaced the mem set with a mem copy. Obviously, I noticed that and I fixed it later. But yeah, this is how I try to optimize stuff on the Dreamcast. I look first if I can draw like optimized functions for the Dreamcast. And CalCOS was actually planning them to be as part of the actual library, but due to licensing issues, they were not able to. So instead, it is part of another library that you have to use. And then eventually, I fixed the issue with the mem set, properly fixed. I also changed the low memory devices to no logo, so I can test between both without doing like too much changes. And really, that's about it for now. Now, I was wondering if a port to the Dreamcast was possible. Well, yes, it is, but obviously it's still not working. But what about the N64? And unfortunately, you will have to drop the Pixman dependency. You will have to drop the BPP to like 16 megabyte, 16. So RGB 565. Well, no, it's 565. My bad. Which is 16 bits color, also known as high color. And yeah, it will be kind of a tight fit on the N64. It's not going to work out of the box. The GameCube would work. There's a port of HDL, but it's kind of suboptimal. You could do like a port that just use indirect texturing, then output the frame buffer to that. The new SDL2 port, I believe, does that, so this could be used, especially to save on memory. The PlayStation 2, someone actually did a port a while back of the PlayStation 2, but he did like a straight port. He didn't try to optimize for memory, and also it was quite big. So yeah, I don't think it ever ran well. And also he still used SDL, even though on the PlayStation 2 you can target, you can push stuff to a texture and then output on screen. You can do that. and you can even do like 240 upscale to 720p or even 1080i or 1080p for that matter. Yeah. So that's all there is to it. Thank you for watching and bye.